Previously, we learned that a conditional statement is an if-then statement, and you have a hypothesis after the if part and a conclusion after the then part. So in this conditional statement, if a number is even is the hypothesis, then it is divisible by 2, that's the conclusion. We learned also how to find the converse by switching the hypothesis and the conclusion. If a number is divisible by 2, then it is even. So now the conclusion came first and the hypothesis second, based off our original conditional statement. A biconditional statement is when we make this a little bit stronger by combining those two together. It's a statement formed if the given conditional statement and its converse are both true. So for the conditional and converse given, determine if the statements are true or false. If they're both true, rewrite the statements as a biconditional statement. So if a number is even, then it is divisible by 2. Well, even numbers are, by definition, numbers divisible by 2. We have 2, 4, 6, 8, 10, and we can keep going up by 2. Every single one of them is divisible by 2. The converse, if a number is divisible by 2, then it is even. That's also true. If you can divide a number by 2, it's got to be an even number. If it was an odd number, you'd end up with a decimal. So this is also true. If either one had been false, if the conditional statement itself was false, or the converse was false, or both of them were false, if you ever get a false statement, then you just can't write a biconditional statement. A biconditional statement only exists if both statements are true. So to combine them together, we start with the hypothesis. In this case, the hypothesis is a number is even. So we're going back to the original conditional. We start with that hypothesis. Then we make the statement if and only if. Those special words mean the original conditional statement is true, and when you find the converse, that is also true. So a number is even if and only if it is divisible by 2. So that takes information we got from two separate statements and combines them together. Because we could write this biconditional statement, we only need this one sentence to know that both of these statements are true statements. We can also take a biconditional statement and decide if it's true or false. If it's a true biconditional statement, we can separate it into two separate statements. So identify if this is a true or false biconditional statement. If it is true, rewrite it as a conditional statement and its converse. So the first example on this page is a shape is a polygon. This is the hypothesis. Then it uses the special words if and only if you can find the area. So finding the area, that's the conclusion. So if we were to write this as its conditional statement, we have to think about this at least, even if you don't write it out. We have to think about it to identify if it's true or not. If a shape is a polygon, you can find the area. Then you can find the area. That is a true statement. For every polygon we know, polygons are shapes made up of straight lines, we can find the area of those. We have formulas to find what's the amount of space inside. So then we think about the converse. If you can find the area of a shape, then it is a polygon. Well, if you can think of a counterexample to that, then it's not true. And I can think of the counterexample of a circle. This one is a false statement. Even though the first one is true, the second one is false. You have that counterexample, a circle is not a polygon, but you can find the area. So this original biconditional is false. So we can't split it into its two separate, even though we had to think about them, that doesn't answer the question. Since it's false and both statements aren't both true, we just answer with this is false. So let's try the next one. So the next one, an animal is a mammal. So that's our hypothesis. If and only if it has fur. Sorry, spelling error there. So let's think about the conditional and its converse. So the conditional statement would be if an animal is a mammal, then it has fur. So that's a true statement. Mammals, by definition, have fur or hair, and that's what makes them a mammal. The converse, we flip the two, hypothesis and conclusions. If an animal has fur, then it is a mammal. This is also a true statement. So when it's true, the answer will be yes, it's true, and you can write out these two true statements. See, kind of, even though, like the false, we didn't need both the conditional and converse statements, we still had to think about them in order to answer whether it's false. So you kind of have to at least think about, well, what's the conditional, what's the converse, before deciding if your biconditional is true or false. Then, if it's false, you're done. If it's true, the answer will actually be written out as, here's the conditional part, here's the converse part.